Class 12th Chemistry, alcohols, phenols and ethers, and in this video we will discuss about methods of preparation of alcohols. First method is from alkenes, and from alkenes by acid catalyzed hydration of alkenes. Hydration means addition of water molecule, and this addition of water molecule is taking place in the presence of catalyst. That's why this is acid catalyzed hydration of alkene. Alkenes react with water in the presence of acid as catalyst to form alcohols. In case of unsymmetrical alkenes, the addition reaction takes place in accordance with Markovnikov rule. Remember Markovnikov rule in 11th standard? That is, if an unsymmetrical reagent is added to an unsymmetrical alkene, then more negative part of the adding reagent will add to that double bonded carbon atom which bears lesser number of hydrogen atoms. Okay. Now let us see, this is the one common reaction. This is alkene. When react with the water in the presence of H plus ion, this double bond will broken down and we will get this alcohol. Now this is unsymmetrical alkene, that is propene. Then water is added. Then the OH part of water, which is more electronegative, will add to that carbon atom which bears lesser number of hydrogen atoms. That is, these are the double bonded carbon atoms, and this one contains lesser number of hydrogen atoms. That's why this OH will add to this and H will go to this and we will get this. That is, propene is converting into propane 2-ol. Mechanism of acid catalyzed hydration. 3 steps are there. In the first step, protonation of alkene to form carbocation by electrophilic attack of H3O plus or H plus. You can see H2O react with the H plus ion and form this hydronium ion. This hydronium ion attack to this alkene and form this carbocation. Okay. And in the second step, nucleophilic attack of water on carbocation. Now this is the water. This will add to this carbocation and form this protonated alcohol. And in the step 3, deprotonation to form an alcohol. Now in this case, either this H or this H will leave. That is, deprotonated is taking place and we will get the alcohol. Now let us see one particular example. If you write, that is CH3CH double bond CH2. Okay, this is propene. When this is added either with H3O plus or H plus, you can also write this is H plus. Okay, then we will get the carbocation CH3CH. Okay, this is positive charge and this will convert into CH3. Okay, now again remember in 11th standard you have discussed this H plus may also add to this carbon. In that case we will get the primary carbocation, but primary carbocation is less stable compared to the secondary carbocation. That's why this H plus will add to this carbon and we will get this secondary carbocation. Okay, and now in second step, this secondary carbocation, you can also write this. This is positive charge. Okay, and this is added with the, or we can say water will attack to this carbocation. This oxygen will attack to this carbon and we will get, this is CH3, this is CH, this is CH3 and this is O, this is H and this H. Now this oxygen gets the positive charge. And in the third step, this protonated alcohol CH3, CH, CH3, this is O, this is H, this is H. Okay, and there is a positive charge on this oxygen. Now either this hydrogen or this hydrogen will remove from this. and these electron pairs will shift to this, and we will get this is CH3, CH, this is OH, and this is CH3. And again this H plus is generated, which act as a catalyst in the first step. Okay, now this is the mechanism of conversion of propene into propane 2-ol. I think this is clear. This is the one of the important mechanisms of this organic chapter. Try to understand it. Now second method from alkenes by hydroboration oxidation. Diborane, BH3 twice. Actually this diborane you again can write like B2H6. Okay, this is the dimer of BH3. Reacts with alkenes to give trialkyl boranes as addition product. This is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. This is propene. When this react with diborane, then again this H will add to this carbon, and this BH2 will add to this carbon, and we will get this one. Now this may further react with the another molecule of alkene, and we will get this one. And this one further react with the another molecule of alkene, and we will get this. This is tripropyl borane. Okay, and this is oxidized by H2O2 in the presence of alkali, that is OH minus ion. We will get the propane 1-ol, and this is a boric acid. Actually, this overall reaction can be written like this. You can say this is CH3, CH, double bond CH2. Okay, first of all, this is reacting with the diborane. You can write this BH3 whole twice, or you can also write B2H6, and whatever the product is formed, that is oxidized by H2O2 in the presence of aqueous sodium hydroxide solution. Then final product is CH3, CH2, CH2 and OH. Okay, now if you compare this one and this one, you will observe that water is added according to anti-Markovnikov rule. Is it clear? That's why now there is one question. If you are asked to convert propene into propane 2-ol, then you have to follow the acid hydration. That is hydration of propene in the presence of acid. Then we will get propane 2-ol. But if you are asked to convert propene into propane 1-ol, then we will follow this reaction, hydroboration oxidation. Okay. Now next, from carbonyl compounds. I think you remember what is this carbonyl compound. This is a carbonyl group. Compounds containing this group are known as carbonyl compounds, and its examples are aldehydes and ketones. That's why by reduction of aldehydes and ketones we can get alcohols. And reduction is taking place in the presence of, that is addition of hydrogen. Reduction is taking by addition of hydrogen in the presence of catalyst, that is catalytic hydrogenation. And catalyst can be used as platinum, palladium or nickel. You can also use the another reducing agents like sodium borohydride, NaBH4, or lithium aluminium hydride, LiAlH4. Aldehyde yield primary alcohols, whereas ketones give secondary alcohols. Now you can say this is aldehyde, this is primary alcohol, this is ketone, and this is a secondary alcohol. You can also understand this is the reduction. How you can understand? Actually, this aldehyde can be written like this. And in the presence of H2, when it reacts with the H2 in the presence of a catalyst, what will happen? This bond, CO bond, is broken down, and we can say this is R, this is CH. One hydrogen, this CH is already there. One hydrogen will add to this carbon, and one hydrogen will add to this oxygen. and we will get RCH2OH, which is primary alcohol. Now in case of this secondary alcohol, take one particular example, like if we take the ketone CH3COCH3, okay, when this react with the H2 in the presence of PD, what will happen? Reduction of this ketone is taking place, and this will convert into CH3, this is CH and OH, and this one is CS3. Secondary alcohol is formed. Okay, that is, this bond is broken down. One hydrogen will add to this carbon and one hydrogen will add to this oxygen. Next one is by reduction of carboxylic acids and esters. Carboxylic acids are reduced to primary alcohols by lithium aluminum hydride, a strong reducing agent. This is carboxylic acid. First this react with the lithium aluminum hydride, followed by hydrolysis. This will give primary alcohol. Lithium aluminum hydride is an expensive reagent. That's why first of all acids are converted to the esters by esterification. Okay, and then esters are reduced using hydrogen in the presence of catalyst, that is catalytic hydrogenation. This is carboxylic acid. When this react with the alcohol in the presence of H plus ion, this will form ester. This process is known as esterification, and then this ester is reduced by H2 in the presence of catalyst. We will get the two alcohols. Now again in this you can see how the cleavage of carbon is, where bond is taking place. Ester can be written like this. Okay, and then this cleavage is taking place from this. This part will convert into this one. Okay, and this part is converting into this one. Now next, from Grignard reagent. This is one of the important method for the preparation of alcohols. Now in this case Grignard reagent react with the carbonyl compound, that is aldehyde and ketone. This representing carbonyl compound, CO group, carbonyl group. Okay, this is Grignard reagent. Now in this case, as this bond is polar, this will acquire the partial negative charge and this is partial positive charge. And we also discussed the structure of Grignard reagent. In this case, this alkyl group is partial negative charge. That's why this R will attack to this. Okay, and this MgX will attack to this oxygen, and we'll get this one addition product. Okay, R to this carbon and MgX to this carbon, and when this product is hydrolyzed, okay, then this will broken down from here, and this H will go to this and OH will go to this, and this is the product. Now depending on which type of carbonyl compound we are taking, we can get the primary alcohol, secondary alcohol and tertiary alcohol. Like if we take the methanol, we will get primary alcohol. If we take another aldehyde other than methanol, then we will get the secondary alcohol, and ketones will convert into tertiary alcohols. And these are the reactions. This is methanol. When react with the RMGX, first we will get this addition product. When this is hydrolyzed, this is a primary alcohol. In case of aldehyde other than methanol, we will get this final product is secondary alcohol. In case of ketone, we will get this tertiary alcohol. Now let us see. All these reactions can also be represented like this. If we take one particular example, like you can take this is CH3CHO. Okay, you can write this reaction like this. First of all, this is reacting with, now in case of Grignard reagent, again we can specify the Grignard reagent, like this is CH3 MgBr, methyl magnesium bromide. Okay, and followed by whatever the addition product is from, that is hydrolyzed. Now just see how can we write the final product. Now in this case, this CH3, okay, this CH3 will attach to this carbon, or H will add to this oxygen. That's why we will get this is CH3, okay, and this is CH, CH3 and this is OH. This is secondary alcohol. Is it clear? Now again, if you take ketone and first member of ketone series is propanone, CH3COCH3, and when you can write like this, first it will react with the, now again you can specify the particular product like particular Grignard reagent, sorry, CH3MgBr, and followed by hydrolysis. Then you can write the formula of product. Now this will be, this is CH3. Now again what will happen? The alkyl group of the Grignard reagent will add to the carbonyl carbon. Okay? And H will add to oxygen. Like this. This is tertiary alcohol. And these reactions are very important to add the number of carbon atoms in the product. That is, this reaction is used to ascend the series. Okay. Now, if you can compare, in this case, 2 carbon atoms are there. But whatever the product form, this will contain 3 carbon atoms. Okay. Now, in this case, 3 carbon atoms are there. Product form contains the 4 carbon atoms. Okay. By changing the nature of this Grignard reagent, you can also change the product. Okay. Now let us see one example. Give the structures and IUPAC names of the products expected from the following reactions. Catalytic reduction of butanol. Okay. You remember the formula of butanol? This is CH3, CH2, CH2. Okay. And this is CHO, CHO. And catalytic reduction means this is adding with H2 in the presence of catalyst. Platinum, palladium or nickel you can use. Now what will happen? This part, carbonyl part. Now in this case, one H will add to this carbon and one H will add to this oxygen. That's why we will get the CH2OH. This will convert into CH2OH. That's why our product is butane 1-ol. Now, hydration of propene in the presence of dilute sulfuric acid. I think you are remembered. We have already discussed. When propene is hydrated, that is, hydration of propene is taking place in the presence of dilute sulfuric acid. Water is added according to Markovnikov rule and we will get this propane 2-ol. Now, reaction of propane with the methyl magnesium bromide. We have discussed this one also. Propanone. Okay. That is CH3COCH3 when added with the methyl magnesium bromide. Methyl part will add it to the carbon of carbonyl group and H will add to this oxygen and we will get this 2-methyl propane 2-ol. Okay student, thank you. Subscribe my channel to get the new videos from this chapter.